Okay, so we're going to start off by looking at the cutaway of the fluid section of the Husky 1050 diaphragm pump. A few enhancements of the 1050 as compared to the 1040, redesigned fluid manifolds, and also we're using a new air valve. This new air valve, the redesign of the fluid section, allows the 1050 pump as compared to the 1040 pump to have about a 20 to 30% more efficient operation. So what that means is if you replace this pump right here, if you're taking a 1040 out and replacing it with a 1050, that you're going to want to reduce your inlet air pressure by approximately 20 or 30% to get the same operation. Okay, so what that means is you're going to have some better efficiencies, reduced air consumption. All right, so what we're going to do is we're going to talk about exactly what these diaphragms and the ball checks are doing in this pump. All right, so right now what's happening is the diaphragms are moving back and forth. All right, and that air valve right up in here is what's causing that to change. All right, one of the nice things about, or features of a diaphragm pump is if I shut off fluid flow to this pump, it's going to stall under pressure. All right, so what's happened right now is it's just stalled under pressure, and I'm going to talk just a little bit about what's going on in the diaphragm area over here. All right, so this diaphragm is pushing in this direction. When it does that, it's creating some pressure, causing this ball up here to lift off of its seat. It's also causing this ball down here to check or to seat. All right, so any fluid that's caught in this chamber right here is going to be pushed up and out of the pump. All right, now over on the other side, what's going on is this diaphragm is pulling back in. All right, so what it's doing is it's creating a low pressure zone in this area right here. That low pressure zone allows atmospheric pressure to push material right here up and into this area right here. All right, so this check ball right here is up off its seat, and also up on the top side, because of this low pressure zone, it's causing this ball up here, right there, to seat down. All right, so this side is loading, and then this side over here is unloading. All right, and now this air valve right up in here, as it's switching directions, basically what it's doing is it's taking pressurized air and putting it either behind this diaphragm or behind this diaphragm right here. All right, so next thing we're going to do is we're going to break away to a different animation and take a little bit closer look at that air valve and what that air valve is really doing. Okay, so now we're going to talk a little bit more about the air valve and the air logic through the Husky 1050 pump. Couple of component identifications. Air valve up on top. 4 bolts on that air valve. It's a modular design, so if you needed to replace it or repair it, 4 bolts, pops right off. Down here, behind this first diaphragm, there's a poppet valve. All right? Over on the other side, another poppet valve. And all those poppet valves do is they're a momentary open air switch, and it's used to dump air pressure on one side or the other of this valve up here. All right, so what we're going to do is we're going to go ahead and stop this animation and take a little bit closer look at the paths that exist on this air valve. All right, so right now on the red, that indicates high pressure air. All right, the blue over on the other side indicates that that's low pressure or venting air. All right, so right now we've got the high pressure air that's existing in this module or this air valve, and it's piped down and just coming down through here and all the way back to the back side of that diaphragm, and that's what's causing that diaphragm in this case to move in this direction. All right, over on the other diaphragm over here, okay, we've got blue. Again, that's reduced air pressure or exhausting. All right, and what that's doing is that's connected right in through here, and it's coming up through the passage. There's a cup and plate up in this module, and it's connecting it to a vent. All right, so what we've got is we've got vent over here, okay, and we've got high pressure from the air valve going to this diaphragm. Okay, so we've got the diaphragm running again, and basically what's going to be going on is we're going to put air pressure on one side, vent on the other side. The diaphragms are going to come in contact with the poppet valves, and that action of the poppet valve is going to cause this spool valve up in this module to be moving back and forth. Basically all it's doing is just directing air pressure and vent from one diaphragm to the other diaphragm.